we've been talking about inequalities in one triangle. Everything we've been doing has been looking at one triangle. Okay? In a triangle, the longer side is across from the bigger angle. Okay? Now we're going to start to look at two triangles. Okay? So these are called the triangle inequality theorems. Okay? Plural, inequalities in two triangles. And you have two of them. There's the hinge theorem, okay, which we can call, I'm just going to throw it out there if this is easier for you to remember. It is a little confusing, so I want to caution you. Side angle side inequality. And what it's saying is that if you have, in two different triangles, if you have two sides that are the same, and then the included angle in one is bigger than the included angle in the other. So here, 43 is bigger than 30. That if you have that setup, that this side has to be bigger than, as long as these sides are the same, then wherever, you got to have two sides congruent, wherever the bigger angle is, the bigger side will be, or the smaller one. And then this is backwards, okay? So if I look at the converse, it just says the opposite. If you have these two sides the same, okay, if you have these two sides the same, these two sides the same, and then this side is smaller than this side, then this angle L would be smaller than this angle R. Okay. So you have those two. So we have to look at things like this, and it says compare AD, just to make sure we understand that. AD is here, all right, and BD is here. Okay. First thing, do we have this side angle side kind of relationship? Do we have two pairs of congruent sides? Okay, yeah, we've got one here, and where's the other one? Okay, the reflexive property. I'm saying reflexive property because I want to make sure when we have a proof that we have to do for these things, you're going to have to say reflexive property. Okay, right? And then I'm like, okay, well, 70 is bigger than 68. Awesome. Which means that AD is greater than BD. Okay? Notice there's no bars on top of these because we're talking about the measurement of them. They're not segments that we're talking about. We're talking about the measures of them. Yeah. Is that okay? Is that the idea on it?
It wasn't the exact question.
Okay. So this one, notice they want us to compare very similar. These angles, I got to be careful here. ABD, that's this one. And then they want us to compare that to, go here, this guy here. Ooh. Okay, which is this angle down here, BDC here. I don't know if they're equal, so I'm going to put a different measure there. But we're comparing those. And I want to make sure I've got the side angle side thing. I've got this side, I've got this side, I've got this angle, or that side in between them. So there is the side angle side relationship. Okay. 5.5 is bigger than 5. So I know that angle ABD is greater than the measure of angle BDC. Okay, now, can everybody see in this situation that I made my greater than sign like really, really large? Yeah. Because I don't want you to think that this is a greater than sign or a less than sign. So just make sure you make it big. You got angles in there. There's just a lot of little angle symbols. Okay. Typically, if you look at like the font on a computer, it'll make your angles with a flat bottom on the bottom. They try to make it flat, and then the greater than signs they'll make it more slanted. But it's hard to distinguish sometimes. So I always make it really big. Okay. Sometimes I'll even do this just to make it obvious. Like circle it so it's different. But I just want to make sure we see that. Okay. I'm not, again, test context, I'm not going to try to trick you. But I want you in the habit of looking for the sides. Because what will happen inevitably is students get to, like the homework will do this once in a while, you'll get to a problem and you actually can't tell. Because they haven't given you side angle side. But students just see 5.5 and 5 and they just decide. But they don't have the sides that are allowed, are there to tell them. So be careful. Okay? All right. So this one, find the range of possible values for A. Okay, so what they're asking you here, same idea. Side here, reflexive property. Okay. 18 is bigger than 16, which means that 141 is greater than 9A. They put their A like this, plus 15. Okay. And so I could solve for A. Subtract 15. Okay. Now, normally I would write that this way, so I want to be careful. Okay. Now, everybody with me? I'm going to add this. The book doesn't always talk about this. I think this is really important. What this tells you is that A can be anything less than 14, and that is not true. Okay? Someone want to give me an example? Okay. A doesn't have to be greater than 0, but the angle itself has to be greater than 0. We can't have a non-existent angle. Okay? So what I tell everybody is the other side of this is that you would want to do this as well. 9A plus 15 must be greater than 0. Okay? So we 5/3, 15 ninths, 5/3. We don't want our angles to be 0 because that means that they're not angles anymore. Okay. So the upper limit will be set by here. What's the biggest an angle can be in a triangle? 180. So let's say the problem started us off and we found out A is greater than. Does that mean A could be anything we want it to be? No, we would have to make sure that this isn't. It has to be less than 180. So you always have a built-in top cap and a built-in bottom. Okay, to leave room for other angles or actually having a triangle. So, Ashley, do you have a question?
Why does the book mention that?
I don't know. Maybe they're like, it's not the end of the world. Maybe they're assuming that we all get that. I just feel like it's helpful to draw it out. Okay. All right. We got a proof here. Okay. Similar, I'm going to guess, to the one in the packet, though not identical. All right. They tell us AB is congruent to BD. So this is kind of awkward, but they are talking about this entire thing. Okay. All right, so that's the dash that's there. All right, and then BC is congruent to BC. Is everybody okay? We see that. Okay, those two triangles share this one side over here. What is that reason? Yeah, reflexive property. Okay, we've been talking about that. All right. And then they do this like kind of thing here where they're helping us to see something. Okay. A little bit trying to draw this out for us. So angle ABC, this big one here. So in the big triangle, the one on the top, you've got this. Here's one side that's labeled, here's two sides, and we're talking about this angle between it. Okay, that's that yellow one. Okay, is greater than these two tiny ones, or it's equal to these two tiny ones added together. Okay, sorry, they're not equal to each other, but okay. That's what this says, right? ABC is equal to these two added together. Do we all see in this smaller triangle, the other one we're talking about, which also has this side and this side, that's the little angle right there? Can you kind of see that? And so, like, if these two, the smaller ones, the green ones, add up to the yellow one, What does that mean about the individual green ones? They have to be smaller. Do you guys remember the definition of inequality? When we said, and I asked it really early on, and I said, how do I know that, like, I think in the notes, this is what it says. How do I know that 5 is greater than 2? And the answer is, like, I know we're all like, because it is. Right? But the answer is because in order to make them the same, where do I have to add something? I have to add something to this side, which makes this the smaller number. Okay? And so that's what's happening here. If ABC, the measure of angle ABC, is equal to these two added together, then these two must be, by the definition, smaller. Okay? That's something to keep in mind. That's the definition of inequality. So now we've said this, okay, that this green one, this green angle here, is smaller than this one. That means, by the hinge theorem, that this side has to be smaller than this side, which is what that says. AC, okay, is bigger than DC. And that is the hinge theorem. So you could write hinge theorem, or you could write side angle side inequality. We go with like some holly leaves today. Is that pretty decent? You get the idea. Christmas is coming, guys. All right. Okay. So let's check out this one. Okay. I'm gonna write out all this given stuff because I want us to see there's a lot that they told us. We'll try to do these one at a time. ST is congruent to PQ. ST is equal to PQ. All right. SR is equal to QR. Right. And then this last one, SP is greater than ST. Oh, sorry, greater than. We'll put 4 marks to 3. No, one's bigger, okay? All right, if you want to leave those off, it's just helping us. Now, this is kind of weird, because notice what they want us to end up comparing here is they want us to compare SRP, this angle, to make sure, PRQ, this angle. Okay, and I did that backwards from the way I just said it, so let me do that. Okay, so they want this one to be smaller than this one. Okay. Now, does anyone see a slight problem with this one? Yeah, like the stuff they gave us. Okay, if I'm thinking about kind of things, if I'm looking at, I don't know, it depends on what you're looking at. If I'm looking at this triangle and this triangle, I was kind of expecting us to say this one and this one, right? And then all of a sudden, it's not the route they went. Like, well, that's frustrating. Okay. So when you first look at it, I think that's what your attention is drawn to. And so you're trying to figure out. Okay. So in my mind, all of a sudden that means like, okay, I'm not just going straight forward with the hinge theorem. Maybe there's a workaround or something else that I have to tie in. Okay. Or maybe I need to talk about figuring out something different. Is everybody okay? Is everybody okay? If I do this, just to help us out a little bit. that this side is congruent to itself. Does everybody now see the hinge theorem? Side, angle, side. The hinge theorem is the same thing, right? It's inequality. And now the key is somehow, some way, I need to say that this side is bigger than this side. Okay. Yeah.
Can you use substitution and just say that right away? Because ST is.
Yeah. Sure. Okay. Notice ST is the connecting piece, right? So I can say that SP is greater than PQ because of substitution. Property. Okay. And this one is not as complicated as it looks. Okay. Because now I actually have the hinge theorem, and I can say that the measure of angle SRP is greater than the measure of angle PRQ because of the side angle side inequality, or the hinge theorem.
As long as we get to side angle side, that's when we can start assuming hinge theorem. Or using it.
Oh yeah, using. I like that better than assuming, because we're not. This is exactly what it says, right?
Yeah.
Right. And again, to be really clear, the hinge theorem says you got two sides that are congruent, and I want to be careful. Technically, this would be the converse to the hinge theorem. Right. Once we have two sides congruent, then we could say either is the angle bigger than another angle or a side bigger than another side. And that's what we kind of go back to. So what we wanted, again, if I kind of undo some of that stuff, we knew that this was congruent to itself. Okay, that's that pink step. And then we also knew that this guy was the same as this guy. So there's your side, angle, side. So, but I didn't know which angle was bigger. That's what they wanted me to prove. So I had to get that this one and this one were compared to each other. That's what we were trying to do. Because there's a connection between this side and this angle and this side.